Good day everyone. Today I'll be giving you guys tips on how to solve questions under stoichiometry in chemistry. The word stoichiometry is combination of two Greek words, stoichion and metron. The word stoichion means particles and the word metron means measurement. The measurement of particles in chemistry is what we refer to as stoichiometry. And particle in chemistry is the same thing as matter. And matter is anything that has mass and occupies space. There are three basic states of matter: solid, liquid, and gas. The way we measure these three states of matter in chemistry differs. Easily we can measure a solid using beam balance and chemical balance. But liquid and gas can't be measured this way, and that is why the volume of the containing vessel is used to measure liquid and gas. Based on these two reasons, stoichiometry is broadly classified into two: gravimetry and volumetry. Gravimetry is the measurement of mass. Volumetry is the measurement of volume. Under gravimetry, we have the concept of mole. And under the concept of mole, we have some set of formulas. And those formulas are what we have in there. Number of molecules is equal to mass over molar mass. Number of molecules is equal to volume over molar volume at STP. Molar volume is always equals to 22.4 dm cube. And also, number of molecules is equal to number of particles over Avogadro's constant. Avogadro's constant is always equals to 6.02 times 10 raised to the power 23. And under volumetry, we have the concept of concentration. A concentration is inversely related to volume. So the first concentration that we have is concentration in mole per dm cube, which is always equals to number of molecules over the volume of the solvent. And the second one is concentration in gram per dm cube, which is equal to the mass of the solute over the volume of the solvent. Concentration in mole per dm cube can also be called molarity, or you say molar concentration, while concentration in gram per dm cube can also be called mass concentration. Under the concept of concentration, there are two applications, and that is the dilution principle and the concept of neutralization. In dilution principle, we are trying to reduce the concentration of the reagent. So the dilution formula is C1V1 is equal to C2V2, where C1 is the concentration before dilution, V1 is the volume before dilution. C2 is the concentration after dilution and V2 is the volume after dilution. Now note, V2 is always equals to the volume of the reagent that we want to reduce its concentration plus the volume of water added. The second concept is neutralization. Neutralization reaction is when you react an acid with a base to give salt and water only. And for that concept, we use the formula CAVA over CBVB equals NA over NB. A is acid, B is base. Na is the stoichiometric factor of acid when the reaction is balanced, while Nb is the stoichiometric factor of the base when the reaction is balanced. Let's consider this question UTME 2009 question 4. 0.0075 mole of calcium triazocarbonate 4 is added to 0.015 moles of a solution of hydrochloric acid. The volume of the gas evolved at STP is. There is a chemical property of an acid that states that when triazocarbonate reacts with an acid, it evolves a gas called CO2. Meaning, in the question, we are to find the volume of CO2 produced. When we react calcium triazocarbonate 4 with HCl, we have the following products: CaCl2 plus H2O plus CO2. And when we balance the reaction, we can see the related mole ratio, which are in ratio 1 to 2 to 1 to 1 to 1. Under stoichiometry, we have two reagents, the limiting reagent and the excess reagent. Limiting reagent has the smallest mole ratio or the number of molecules, while excess reagent has the highest mole ratio and the number of molecules. Limiting reagent controls the reaction. So in the question, the limiting reagent is CaCO3 because it has the lowest number of molecules. And when we relate that with the mole ratio of CO2, we can see that the number of molecules of CO2 is also 0.0075 moles. And we recall that number of molecules is equal to volume over molar volume at STP. And when we cross multiply, we have the volume to be equal to number of molecules times molar volume. And when we multiply these two parameters together, we have the volume of CO2 evolved to be equal to 0.168 dm cube, which is also equal to 168 cm cube. This is how we go about the question. Okay, thank you very much. Have a nice day.